Yesterday, we discussed about how stochastic gradient descent algorithm will help the simple linear regression model to update its model parameter. We discussed the background mathematics, and we discussed the algorithm, step-by-step algorithm, and we did some hand calculations, and we implemented for a sample data set, we implemented on a sample data set using MATLAB also. So today we will implement the same concept using Python. We will implement the same concept using Python. Okay. So that actually we started yesterday, but we are unable to complete it. We are unable to finish it. So today we will start from the implementation of training process of simple linear regression model using the stochastic gradient descent algorithm. Let me share my screen and my Google Colab. So I'm trying to show the implementation in a Google Colab. I want to show the implementation in a Google Colab. Okay. So just I'm open the Google Colab here. So this is the Google Colab. So just I want to give some name like SGD based simple integration model training, SLR, for sample data. Let us assume. So this is the name I am giving here. So now what things are required? So first in Python, we need to import the all required libraries. Okay. So what are the libraries are required? So the main required libraries are import NumPy and import math library, import random, and also import pandas. Okay. So I'm trying to copy the complete steps and I'm pasting in this cell. So I'm trying to import NumPy, math, random, and if you want, you can write import libraries. Okay. So you can write the comment like this. And if you want to shift it to the on top, it will be like this, import libraries. And here we are importing the libraries. So once I importing the library is completed, what will be the next step? So we know that next step is initialization. Now go for the initialization part. Go for the initialization part. Go for the initialization part. So here what we have to do? What we are going to initialize? First, I am trying to initialize the eta at 0.9. And I can initialize the number of epochs equal to some 1000. And anything else we need to initialize apart from these two? We need to initialize the model parameters, right? So what are the model parameters? So M, one is one model parameter. So how we randomly initialize the model parameters M and C? So M equal to random dot uniform. So in the range of -1 to 1, some value, you can take any range. Similarly, you can initialize the another model parameter randomly, that is the random dot uniform, the range of -1, 1. Okay. So that's it. I think these are the 4 things we need to initialize, right? As per our, otherwise we will go for the our step-by-step process also if required. We will discuss that one. I think this is the step-by-step process. Yeah, this is the step-by-step process we will see here. So what we are going to initialize? We are going to initialize M value, C value, eta, number of epochs, and also number of samples, and also we need to read the data. We need to read the data. Okay. So how we read the data? So data equal to. So please, I think everyone following. If you have any doubt, you can unmute yourself and you can ask that question. I will try to clarify. So actually, where the data is available? Actually, the data is available in my local computer. The data is available in my local computer where it is a role of optimization, whereas in stochastic gradient in practice. So there's the data, sample data. Okay, this is the sample data. This is the X value, input value, and corresponding output value. So we have to train the model based on this data. Once the training is completed and the trained model, we are going behind an application. And once we give the some X value, it is able to predict the Y value. That is the process we are going to check. Now, actually, the data is available here, right? Sample underscore data. But where we are writing the code? We are writing the code in the Google Colab. We are writing the code in the Google Colab, but my code, my data set is available. My data set is available in the local machine. So how we import the data from my local machine into the Google Colab environment? How we can import the data? So you can see here a folder. So click on this folder. Click on this folder. And here you can see an upload document icon. Upload a session storage. Upload to session storage. So upload here. Click on that icon. And where the data is available, under role of optimization, under SGD, under practice, I have a sample data. Just upload here. Okay. So now my data is readily available. Now copy this path. Copy this path. So from I have to give this path here, and from that path, the data will be read and assigned to the variable called data. So how we read the data? So PD, that is the pandas object PD dot read underscore, because it is the Excel file, I want to use the read underscore Excel, and within the quotes pass our path. Within the quotes pass our path. And if you want to see the few samples of your data, you can use data.head. Then we are able to see the few samples, not all samples, top 5 samples. Head means top of the body, right? So top 5 samples we can visualize by using the code data, that the data object dot head. It will give the top 5 samples. First, we will run this importing the library cell. So the required libraries are imported. And next one is trying to initialize all the required values. Now we are getting the samples. So these are samples. Top 5 samples are available. That's how we can read the data.
ಡ್ಯೂಟಿ ಇಲ್ಲ ನೀವು ನಿಮ್ ಕೆಲಸ ಇದೆ ಈಗ
So please, I am requesting, please unmute yourself. Okay, thank you. Okay, so I think you are able to see this what's called Google Colab notebook now, right? So just I am importing all the required data. Okay, this is the second cell, importing all the required data. Okay, so once we import the complete data, then what we are going to do? So our next step is, so data importing is completed and initialization also completed. Now next step is, see carefully. So actually, when we are implementing a real-time project using any machine learning, generally what we are following in case of the natural learning process. That is, as a teacher, I want to make my students learn something. Then what I will do? I will explain concept to my students, and based on the concept, I prepare a set of questions, and I will explain the set of few questions from that set. I will take few questions from this set, from that set, and I will explain in the classroom during the learning process. That means what are the questions available? That means what the data is available. From that data, few questions I will take, and I will explain those questions in the classroom. And I kept some questions hide. I don't want to reveal those questions, but those are related to the concept only. But I will keep that questions aside, and I will use that the questions which you left. Those questions I will use during the mid examinations or end examination, where it will be, so that I can really test the candidate how he learned my subject. If I in examinations, if I give a question which I discussed in the classroom, maybe he can give the answer, but not a actual learning, right? So I want to test the candidate capability, how he learned the subject. Then I have to give some more questions, some new questions to him in the examination, so that I am testing how he can generalize the concept, how we can apply that concept to solve these new problems, right? So like that, whatever the data is available, whatever the questions are available with me, those questions are split it into two parts. Few questions are for the training purpose during the classroom training, and remaining questions for the testing purpose in the examination. The same process in the machine learning project also we are using. So in this machine learning, we have to split the data randomly. We have to split the data for the training. We have to split the data for the testing.
ఎట్లా మేడం ఆటోనా
అంటే
మరి ర్యాపిడో బుక్ చేసుకుంటే ఈడికి వస్తుంది
అది ర్యాపిడ్ ఈడికి వస్తాం
So can you please, is my voice is clear? Is my voice is audible?
యా ఎస్
Okay, madam. Okay. So if my voice is not audible, please let me know. My voice is not clear, please let me know. Fine. So what the data? So how we split the data? That is based on the train underscore test underscore split method. So I will try to explain about this train underscore test underscore split method. So just I am trying to use the same line of code in another section. So I have to open one more coding cell, and here I will use this one, train underscore test underscore split. But it is showing with some red mark, right? Because I have to import this method. I have to import this method or import this library, train underscore test underscore split. How I can import this library? So you can see in the Python, there is a libraries called sklearn libraries. From that sklearn, we are going to import these things. So from sklearn dot model underscore selection, what we are going to import train underscore test underscore split. So we are going to import this method, and you have to use this method. So what this method will do? This method will help to split the data for the training and testing. It helps to split the data for the training and testing purpose. Okay. So how it will split, that I want to explain. So we have some data, right? Like X and Y. This is the data we have. Okay. So we have the data like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and corresponding some values, I don't know, 0.64, 0.74, 0.8, 0.9, 0.75. Like this, some data is available with me. Now, when I'm using the train underscore test underscore split method, then this is the data set. It is my data set. Okay. So when we are applying the train underscore test underscore split method, then what happened is these samples will be splitted for the training purpose and the testing purpose randomly. Okay, the whole data set will be split for the training purpose and also for the testing purpose randomly. So again, in the training, we have the input and output. In the testing also, we have the input and output. So in the train split method, we have to mention what is my test size. I have to mention what is my test size. Suppose if I am mentioning the test size equal to something like 30%, let us assume test size equal to 30%. Let us assume I'm saying 30% is 0.3. If the test size is 0.3, then what is the total number of samples, test samples? That is the 0.3 into number of samples 1, 2, 3, 4, 5, 6. So 6 samples. Out of 6 samples, 30% of samples should be go to the test. So that means it is the 1.8 is approximately equal to 2 samples. So 2 samples are going to the test and remaining samples will be held in the train. So which 2 samples will go to the test side? That will be randomly selection, random selection. Maybe it may choose 1, 2 or 3, 4 or 1, 6 or 5, 6, something randomly selected. So let's assume, so randomly this 4th sample and this 6th sample is selected, let's assume. Then my test data is 0.4 and 0.9. And it here is a 0.6 and 0.8. Okay. So whereas remaining all the samples comes under the, so comes under the training. So what are the training we have? 0.1, 0.64, 0.2 and 0.74. And it is a 0.3, it's the 0.8. And we have the 0.5 and 0.75. Remaining samples are training. So like that data will be split. Now again, so you can observe once we apply the train underscore split underscore train underscore test underscore split method, you can see the terms X train, X test, Y train, Y test, what it will be. So this method throw these 4 parameters, 4 values. What are the 4 values? What are those 4 values? What are the input values in the training? The input features in the training. So this is called as X train. So these samples these values are stored in the X train variable. And what are the output values in the training data that is stored under the Y train? Okay. Similarly, under the test, what are the input features or X values and the test data? This comes under the X underscore text. And what are the output values in the test data that comes under the Y underscore test? So like that, that whole data will be splitted like this for the training purpose, and later it will be splitted as a what are the inputs in the training, what are the outputs in the training, what are the inputs in the testing, what are the outputs in the testing. Like that, that will be splitted. That's how the train test split method will be works. So if you observe here one more parameter, I said yesterday, so random state equal to 10. So I said that the splitting of the data will be done randomly. Why it's only 0.4, 0.10, 0.6, 0.8 here? It is randomly selected. Suppose if you want to run the same cell again, then what happened this time? It may take 0.3, 0.8 and 0.5, 0.7. If you run once again, it may take some different values. It will randomly chosen. But if you want to choose randomly, but the same values want to keep every time when you are running the code, then you have to use the random state with some numerical value, some number. Okay. So I'm giving the random state equal 10 something. Then every time when I'm running the code, these 2 samples go to the test and remaining all samples are under the training process. So this is how we are splitting the data. Okay. So we're splitting the data. So this is the data actually variable where your complete data set is stored. Data is a variable where your complete data is stored. Right. So now how we are passing the values, you can see here how we are passing the values. So actually this train underscore test underscore split method will provide the training input, testing input, training output, testing output. So those are the returns from this function or method, train test split method. And you have to pass the input. What are the input? In the original data, what are the inputs? In the original data, what are the outputs? Then you may have a question, sir, why you are using the data.x? We are using data because my data is stored in the data variable. That's why I'm using the data. Why .x? My input values are my input values are available in the first column with X column. That's why I'm using the .x. You can see data because my variable that has the data, that means sample data is available at data. So I'm using the data dot here input, here output I have to feed. Input is available in the X label column. Output is available in the Y label column. So that's why I'm using data.x and data.y. Okay. And similarly, test size equal to 0.10, that means 0.1, that means 10% of data I want to use for the testing, and remaining data I want to use for the training purpose. Random state equal 10, I told what is the necessity of this one. Now simply run this code, then the whole data will be splitted, what I told in the earlier case. So once that the function is completed, then data will be separated like this, like a training data and testing data, X train, Y train, X test and Y test, like that the data will be splitted. So that's also over. So once the data is splitted, then what we are going to do? Any suggestion? What next? Data is splitted. Then what we will do? Anyone, please? Because yesterday using MATLAB we implemented. Now I'm using the Python. I am implementing. That's it. So what next? Anyone, please?
We'll need to know which one is training data and which is test data, because it is
Madam?
randomly going to be selected.
But here we are mentioning the parameters. So I want to
Yeah.
share this one once again. Yeah. Whole screen I will share. So you can observe our Google Colab notebook here. We are mentioning the first part is the training input. Second is the X test, which holds the testing input. This contains the training output variable value. This is the testing output variable value. That is splitted now. So next step is we are going to use our algorithm. Data we are splitted. And which data we will use to train our machine learning model? So which data we will use to train our machine learning model? Which data? We have the 4 parameters, right? Which parameters we will use to train our simple linear regression model? Because our SGD algorithm will update the model parameters of the simple linear regression model. So which data we will use? We will use this whole data, or from this one you can choose any.
X train.
X train and Y train.
By
Because
train.
yeah, so this is the data I want to use to train my model. This is the data I want to use. My model will learn based on this data. And to test the model, I want to use this X test and Y test. I want to use X test and Y test to test my model. Right? So now we are going to write our code. That means stochastic gradient descent algorithm. That code we are trying to write now. Okay. So before writing that code, so I want to write a small function. I'm trying to write a small function. So what this function will do? Anyone, just by seeing this code, this function is doing. Just I'm writing a function. So here what we are doing? Here we are splitting the data. Split data. Okay. So next what we are doing? Anyone tell what is the function? What is the need of this function? What this function is doing? What this function will do? I'm writing in Python. We are writing the function like this syntax. So we have to write def, that means define. You have to write some name. It is your choice. What name you want to use, you can use that name. Gradient is the name of the function, and that function expecting the 4 values. One is the model parameter M and model parameter C. It is also expecting the input value, input features from the dataset and output variable from the dataset. And it is doing some process and return those values. So what is doing here? What are the values are available here? Those values are written from this function. So what it is doing here? What this gradient function is doing here? Madam, something please.
Finding the GM value.
Yes, that's it. So otherwise, if you have any doubts, that's better to keep this one as a GM. G underscore M, and this, sorry, G underscore M, and this is the G underscore C. Gradient calculation. Here we are doing. That's it. I'm writing a function separately. I'm writing a function separately. Okay. So GM and GC. Suppose if we create a here, so I have to return the same gradients GM and GC. I have to return. Hope you understand, right? Okay. So otherwise, suppose if you are facing difficulty with the functions, if you are facing difficulty, then what we will do? Simply delete this one. Don't write any function. Don't do anything. So what I have to do is just write the code directly. Now tell me how many for loops we need to use when we are trying to write a code for this learning process using the stochastic gradient method. How many for loops required?
2.
2 for loops. So outer for loop for iter in range of what we have to pass here. Anyone please? Iter range. So in this column, what we have to pass? The outer loop for the iterations. Inner loop for the. I think yesterday we discussed actually. Otherwise, I will share this one also. So outer loop is for the iterations. You can see somewhere here. Yeah. So this is the outer loop. Outer loop is for the iterations and inner loop for the samples, right? So you have to, for the iterations, right? How many number of times that outer loop will be repeated? That is depending upon the number of epochs that we initialized earlier. Number of epochs. Okay. So just I am passing that one. Okay. Next, what about the inner loop? For sample in range. In range of. So what we have to pass here? What we are going to pass here? So what we are going to pass here? Sorry. So yeah. So what we are going to pass in this range? Outer loop is based on the number of epochs or iterations. What about the inner loop? Anyone please? Inner loop. How many times the inner loop will be repeated? How many times the inner loop will be repeated?
N times.
N means number of samples, right?
Yeah.
Yeah. So number of samples in which training or testing? Number of data samples from the training or from the testing we have to consider?
Testing on.
No,
Training
here
time.
we have to take the number of samples of the training because the training data is used to train our model. All the samples available in the training data, so that those data we have to use. That means if you write, so print print, so x underscore train. So this is the data, training data. This data I have to use to train my model, right? So we need to repeat this inner loop until all the samples covered in the training data. How we get that information? All the samples are depending upon the how many number of rows are there here. 1 row, 2 row, 3 row, 4th row, 5th row, 5th row, 6th row. That means number of rows are here. 7 rows are there. 7 samples are there. How we get this information? Understood, right? I want to repeat once again. While writing a code, yesterday we write in MATLAB. I think I want to share that also. See. So there are the 2 for loops. Outer for loop for the iterations, inner for loop for the sample. So in outer loop is repeated from 1 to number of epochs. Inner loop is repeated from 1 to n. N means total number of samples in the data. Here I have a very small data, right? Here I have the only 2 samples of data. I don't want to split them. I want to use the whole data for the training purpose. But now in the current scenario, I have the more number of data so that I'm splitting the data for the training purpose and testing purpose. And I want to use the training data only. So we are going to update the samples. We are going to repeat our algorithm sample by sample while taking the samples from the training data. So we have to take the how many number of samples are available in the training data. That information we have to extract. Please tell me how we get this information here. N equal to size of data comma 1, right? This is how we used in the MATLAB. But whereas in case of the Python, how we use? So let's assume that information we can extract. So N equal to, how we get that N value? So that is based on the number of samples in the training data. Control C, xtrain dot shape shape of 0. Shape of 0. That means what it will give? If you keep 0, it will give the number of rows. If you keep 1, it will give the number of columns. Previously in MATLAB, if you keep 1, that will give the number of rows. If you keep 2, that will give the number of columns. But here, if you keep 0, that will give the number of rows. If you keep 1, that will give the number of columns. Now this pass this N here. That's it. Now tell me, where outer loop is completed, inner loop is also initiated. So inside the loop, what we have to do? Inside the loop, what we have to do? Anyone, please? Inside the loop, what we have to do? Please. Okay. Otherwise, so inside the loop, we have to calculate the gradient. So GM equal to, how we calculate the gradient? We know -1 multiplied by M into what we required? M into, sorry, not M into, it is a -1, Y minus, Y means output value. Output value is available where? So which output we consider? Y train or Y test? We have to consider the Y train. So we have to take Y train values. So you can use, you have to take Y train value. So this is the Y train dot ilog of that sample. So -1, this is the Y train. That means the output value is Y train. So from this Y train, whatever the sample passing, that sample we have to log and give that value here. That is means output value minus M multiplied by Y minus M into X. X means X train. X means X train dot ilog. And we have to pass the same sample in X value we have to consider. And minus C and multiplied by X. X means the same. Done. Okay. Similarly, GC equal to, so what change from the GM to GC? Can I copy the complete line as a GC also, or I need to change anything? Can I use the same line here, or I need to change anything to calculate the GC? Can I use the same GM expression for GC also, or I have to change anything in the GC expression?
That multiple X train has to be
Right, madam.
removed.
So we need to remove this X value. It's not required. So we calculate the GM and GC. Once the GM is GC completed, what next? That is the gradient with respect to M calculated, gradient with respect to C calculated. Next, what we have to calculate? That is the
Testing.
delta M and delta C. So del M equal to, how we calculate the del M value? Minus eta multiplied by GM. Similarly, del C equal to minus eta multiplied by GC. Okay. Now, del M del C calculated. That means step length is calculated for every variable. Next step is we are going to update the model parameter. So M equal to M plus del M. Sorry, del M. And C equal to C, what's called C plus del C. That's it. That's it, right? So it's simple. That's what we are doing in the MATLAB also. You can see here. In the MATLAB also we are doing same. GM calculation, GC calculation, del M calculation, del C calculation, M update, C update. That's it. Okay. Now that's over. So the training was completed. The training was completed. Then the training was completed. Now, if you want to print what are the values of x and y, you can print that. So you can write x equal to percentage some 0.2f, comma, y equal to percentage 0.2f, comma, m, comma, c, model parameters. Okay. So first we will run this complete training process. So the splitting is completed. Now we are trying to run this part. So training was completed for the 1000 reports. Now you can print the M and C values. So I'm getting the M and C values. So 0.2 and 0.59. 0.2 and 0.599, that is approximately equal to 0.6. So that is the M and C value. Sorry, not X and Y. Sorry, it is the M and C. M value, model parameters are M and C, right? So M value and C value. Now what next? Generally, what next step is, before going to the deployment, actually in the MATLAB, I didn't explain because it is a very, very small data. I didn't split the data so that I'm not going to, I'm not discussing about the various types of the errors, right? But I told that yesterday, so let's assume myself and my client are happy with the training and testing performance errors in performance in terms of the error metrics. So myself and my client both are happy. So I am directly going for the deployment. But here that does not happen actually. I'm not, yesterday I didn't visualize that part. Now I want to go for that part also. Analysis of the performance of the model. That means error computation. Now we are going to do. So model training was completed. Now we will work on the calculation of the errors. So calculation of the errors means before going to explain the calculation of the errors, I'm trying to explain what is the error, how we calculate the error values. So different errors, no need to calculate all the errors, but for understanding purpose, I'm calculating all the errors for this application. So there is one error is called as mean absolute error. So mean absolute error means if there is n number of samples in a training data or testing data, then 1 by n sigma I equal to 1 to n, and the difference between absolute value mod, difference between the actual output value, what my model is predicting. So this is how we can calculate the mean absolute error value. Okay. Similarly, we can calculate mean error. So mean square error is nothing but the, again, mean. Again, it is a mean. So mean square error is 1 by n sigma I equal to 1 to n. And whereas it's a square error. Square error, so it is a YIA minus YIP whole square. This is the mean square error. And sometimes we are using the mean absolute error. Sorry, root mean square error. Root mean square error. How we calculate root mean square error? The name itself says that root of mean square error. That means whatever the mean square error you have, 1 by n, sigma I equal to 1 to n, actual value minus my predicted value is whole square. That is the mean square error under root. So this is called as the root mean square error. These are the different error metrics which are used to evaluate the performance of a machine learning model on the both training data and the testing data. So we have the train data. That means X train and Y train. And we have the test data. So we have X test and Y test. We have the X test and Y test, right? Okay. Right. So what we have to do? So first, if you want to calculate the errors in the training process, suppose if you want to calculate the errors in the training process, what we will do? So pass all the trainings input X values, input values, training data, input features or input values or X values, pass to your machine learning model, and whatever the YP values are coming, you can keep it as a matrix. So predicted values, you have to keep it as a separately. For this X value, this is the predicted value. And whereas these values are the actual values. Your data set values are the actual values. What are the predictions from your simple linear regression model? That is the predicted value. Now, these values are considered as a YIA and these values are considered as a YIP, and calculate the difference and take the module, add all the samples and take an average. Right? So YIA is nothing but the actual output values coming from the data for a given X value. And YIP means whatever the model is predicting for the given X value. So calculate the difference for all the samples and add and divide it with the number of samples, training samples, it will give the mean absolute error. If you take the square term, it will give the mean square error. If you take the root again, it will give the root mean square error. I think it's clear how we can calculate the errors, right? So now tell me, if you want to calculate the errors, what is our first step? What we are going to do? If you want to calculate the error, what we are going to do? Want to calculate the first step, what we are going to do? So first we have to calculate the, before, if you want to calculate the error, what we require actual output value and predicted output value, right? Actual output value, okay, it is available in the weight train for the training data. It is available in the weight test for the testing data. But predicted value, how we can get? So we have to predict the value. We have to predict the value using your trained machine learning model. So trained machine learning model means you have to use the updated MNC values. Okay. So this is the piece of code I am using. So first, this is not doing anything. It is only converting our data frame into the array format. Array format only it will converting. Otherwise, it will throw some error here. So what next I am doing is, I am passing the every input to my trained machine learning model, and I'm calculating, I'm getting the predicted output. And that output, I want to store it in a matrix or an array. Okay? For that, I am writing this piece of code. I don't want to type again. So we are lagging slightly. So see, I am creating a variable y pred_train with a empty array. No data is available as of now. Now what I am doing, for I in xtrain, whatever the x values are available, whatever the input values are available in the xtrain, I am taking those values one by one, and that value is multiplied with m and added to c. Whatever the resultant value is coming, assigned to a parameter called yptr, and that yptr added to my empty matrix. That means this spread train contains all the predicted output values. Predicted output values. Okay. So you can run this piece of code. And if you want, you can visualize your predictions. So print y_pred_train. These are the YP values. These all are the YP values, predicted values. Anyone can tell me where the actual values are available? Where the actual values are available? Print. Where the actual values are available? These are the predicted value from the model.
In training.
In train, Y train, we have the predicted value. In the Y train, we have the predicted value. We have the predicted value. Our luck is, whatever our model is predicting, the output value is also same. And it is the training data. So if I'm saying my child, it is a, so if I'm asking write a, it is it write she write a also exactly. So like that it is getting. That means it trained well. Now what we have to do, we need to calculate this is the predicted value on the training data. This is the actual value on the training data. Now we are going to calculate the errors. For errors, we can write the code from the scratch using Python, or it takes some time, or you can use already existing libraries available in the Python. So what are the libraries are available? So using those libraries, we can easily calculate our error. So this is our error or training errors. Okay. So root mean square error equal to empty dot square root. That means square root of what? Mean squared error. This is the method available in the Python to calculate the mean square error. Mean underscore squared underscore error is a method which is available in Python to calculate the mean square error. Whereas mean underscore absolute underscore error is available in Python to calculate the absolute error. But what it is expecting what is the actual output, that is the Y train, and what is the predicted output, that is the Y pattern we had to pass. If you pass these two, it will give 1 by n sigma 1 to n ya minus yp value modulus. We are passing to the mean square error, right? So what it will do, it will calculate the 1 by n sigma I equal to 1 to n ya minus yp whole square value and root. It will give the root mean square value. And here no root. because the mean square error only. So mean square error means mean underscore squared underscore error. That is the method. You have to pass the actual output value and you have to pass the predicted output value. Similarly, for mean absolute error, you have to pass the actual output value and you have to pass the predicted output value. Now it is showing some error. You can see red mark, red mark. So why? Because we have to import that error, that method. These methods we are going to import. These methods we are going to import. So you have to import from the sklearn matrix. From sklearn matrix, you can import the mean squared error and also mean absolute error. Okay. So from where we are going to import these things. Once you import, you need to import again and again. But till now we are not imported those methods. So we have to import now from sklearn dot matrix import. What we are going to import? I want to import mean squared error. And what else? From sklearn from sklearn dot matrix import. What we are going to write? What we are going to import one more? Mean absolute error. That's it. We no need to import the root mean square error separately because we are calculating the square root of your mean squared error. It will give the root mean square error. Okay. So simply I am printing those values. Simply I am printing those values. Any mistake here? Mean underscore absolute.
Second line commas
Where, sir?
from training accuracy second from
Right.
sklearn
Thank you
dot.
very much, sir. Yes, it's a dot. From sklearn dot matrix import mean absolute error. Now it's showing that errors. All the errors are almost all are equal. 10 to the power of minus 17, 10 to the power of minus 13, 10 to the power of minus 17, almost equal to 0. All errors are 0. What next? So training errors are almost equal to 0. Let us assume I am very happy. So then what we are going to do? So I'm happy. Okay. So if you want, you can calculate the test errors also. So bad training error. Next, what we are going to do? Test error. How we calculate the test errors? How we calculate the test errors? We are going to calculate these are
Use-
error based on the training
Use
data. Right?
Y-train instead of Y-train, use Y-test and
Yes, madam. So now
Instead of
I am using the same piece of code again. Just I am using the same piece of code again. Okay. Just I want to rename something. It is a prediction on the test data. And input you have to take from test data input. Right? We take the, because I want to calculate the error on the test data. You want to calculate the error on the test data, you have to feed the input from the test data and you have to compare that predicted output with the output from the test data. That's all the actually we are comparing, calculating error. So I am initializing a null array, no data is available, empty array. Now from the test data, I took every input and that input is multiplied with m value plus add the c value. Then whatever the value is available, that is stored in the y underscore p underscore some ts variable. And this is the y-pred test. In that test, we have to append that information. It is the ts value. So this value, I have to store it in this array. Now, so convert this one to the array form. That's it. Now you have to run. Now it will give the predicted output value. So if you want, you can click here. So it will give the predicted output value. So print of, so what's called y-pred test. Sorry. So print y-pred test means what it means? Predicted values. The y-pred test is nothing but the contains a values, predicted values of a simple linear regression model on the test data, test input data. And if you want the actual outputs, so from where we get the actual, this is the predicted output from the test data, and from where we got the actual outputs in the test data, that is from the y underscore test. So that contains the actual values of the test data. That's it. So surprisingly, I have only one sample in the test data and the both values are same, both output values are same. And now if you want to calculate, of course, as we know, outputs are almost same. You got the errors also 0, testing errors. Now I'm trying to find the test error. So test error or test errors actually. So no need to import once again, because already we are imported again previously. And what change I have to incorporate here? I want to calculate the errors on the test data.
We'll have to change the
Right. That's it.
predicted train.
So y test
predicted
with
test.
here actual values are we have to change with the test y test, and predicted values are changed with the y pretest value. That's it. Now if you run it and you can see the error. So if you observe, so if you observe here, so you have the errors are 10 to the power of minus 16 and 10 to the power of minus 32 and 10 to the power of minus 16 almost equal to 0. Now my errors are, training errors are almost equal to 0, testing errors also almost equal to 0. Then what next? So I am happy with my errors during the training process, during the testing process. I am happy with my model performance. So my client also happy. Then what next? So previously,
You have to deploy.
just deploy the model. So write a small code to deploy the model. So deploying model is nothing but deploying the what mean by the deploying model in backend of application. In backend of application, deploying a model is nothing but just deploying the M and C values. So what is the M value here? 0.2, C value is 0.6. Okay. So M value equal to M value equal to 0.2 and C value equal to 0.6. What next? An application, what we are expecting. So for a model, we have to give the X value, it will give the predicted output. That X value may be a load at 1 hour before, load at the 24 hours before, whatever the approach we are using for the load prediction or some other parameter. That input you have to feed to the model. That input we need to feed to the model. Okay, now you can write like load 24 hours back is equal to, so it is asking input, it is asking enter, load 24-hour back, load we have to enter. It is asking like that. So what next? Suppose user is entering so this is the load available in the subsystem yesterday. Now predict the load in the next day. That means next hour. So to calculate the prediction, what we are going to do with that application backend, I want to deploy the simple linear regression model. Deploying the simple linear regression model means deploying the model parameter and
Y equal to MX plus
right.
C.
That architecture of the model, machine learning model. So architecture of the machine learning model, that is the load. It predicts the Y. Y means let us assume it's the load. So load equal to, that is a variable. We can use Y also. Load equal to, so M multiplied by input. That is the 24 hours back load plus C. Right? But it throw an error because it's like when you are entering some data, it will be considered as a string. We have to convert into the numerical format, use the typecasting, float. So float, then it will be converted as a floating point number. Otherwise, it will consider the string. I am trying to multiply my string with the M.2 value, then it will throw an error. So try to convert that one into the numbering format. So once you got the load, so what is required? Once the operator enters the load value, yesterday's load value, what is expecting? He want to see the output. So you have to print that output. Print next hour load equal to percentage something 0.2 F, comma. So where it is available with the load variable. That's it. Okay. So simply run this application. This is part of application. So it is asking what is the load value. So let's assume, so we have the data right already. So you can take, so generally I'm to check our values. So I'm entering some value, like let us assume I want to enter the 0.6. So let us assume my value is equal to, the value equal to 0.6 and enter. That is our application, right? So what is the value it is giving? Next hour load equal to 0.72. So if you observe this data, you're able to see that one also 0.72. I'm not feeding points directly. My model learn, and whenever it is a 0.6 giving, and it is able to predict as a 0.72. So this is all about how we write a code in Python to train a machine learning model, simple linear regression model using the stochastic gradient method, and also to split the data, and also to get the predictions from the trained data, test data, and also to calculate the errors. If you are satisfied with the errors, also to build the application. This is the complete flow of any machine learning project. And few more steps are there. I don't want to go in depth again. There's the data processing, all the things are there. Just as of now, I'm holding that one. So this is the complete pipeline of this machine learning project. So we're going to feed the data and later run the algorithm and later calculate the predictions on the training data, testing data, later calculate the errors. If you are happy with the errors, then go to deploy the model. This is the complete flow of the method. So I will share this with you all. Done. Okay. So that's over, right? Now I'm trying to work with some more small case study. So later we will stop this lab work, and later we will move to the some other optimizer. Okay. So what the another thing I want to discuss with you is, I think in the what's called in the brochure I have given that how we estimate the number of bicarbonates available in the well water based on the pH value. See, whatever the problem statement, only the name of the parameters changes. Again, we are dealing with the data only, right? So our problem statement here is, we are trying to build a simple linear regression model to estimate the number of bicarbonates in a well water based on the pH value. Based on the pH value. So for that one, the data is available somewhere. So now I move this code very fastly because you already know how we work on it. So you already understand the complete pipeline of the project and the code. So that for this exercise, I will move fast. So going to the optimization. Yeah. So it's from Union Carbide technical report. So we have that data. Give me time, please. Later we'll move to the Union Carbide. What had? Just a minute, please. No problem. Okay, leave it, no problem. So actually what the data I want to download, so that is already I stored in my local machine, but I want to show the data from where I took. Actually, I want to show the data, but unfortunately, yeah. So this is the groundwater data set. So here I got the data from here where groundwater survey. From here I am downloading this data. From here I am downloading this data. Okay. So if you want, I will share this link also. So you can download all the data data sets what I'm using for this training purpose. These are the data sets. Okay. Is it okay, right? So now this data is already available, already kept in my local machine. Already I kept this one in the local machine. So somewhere in the practice. So I think this is the SLR09. So this is my, this first column is about my pH values, and these are so what we have to do, just maybe need a small modification in the code. It's very, very small. That means I want to add one more one more step. So please listen. So after this, I will stop. I will skip for the next optimizer. I will skip for the next optimizer. Okay. So just open a new notebook. Open a new notebook on the drive. Open a new notebook on the drive. Okay. So I think now we are able to give an answer if you understand what I'm saying since yesterday. So tell me, what is the first step? Please, anyone, please tell me what is the first step?
Importing libraries.
Right. So just import the I'm using the same code. So import the libraries. I'm importing the libraries. So I want to give this file name with something like SGD, SLR, water survey, water related activity. Okay, just import the library. So next step is same as random initialization. Initialization, right? So I'm using this piece of code here, and I'm not incorporating the text comments because you are aware of what you are doing in every cell. Tell me if I run this cell, it will give the out. It will run properly, or it will throw any error. If
It
I
will
share,
throw error
it will throw error. The reason is it is
as it
checking
is.
for the sample data, but no data is available in this my instance.
Yes.
So, but now it is sample data is available. Sample data is available here because we uploaded, right? Sample data is available. So now we throw the error.
No.
No. So can I proceed, or I have to change anything? What? Spelling is mistakes. Okay. Let us assume just I'm trying to copy the path. Okay. Copy that path and run. Why? Any? Okay, sorry. So this is the sum folder. This is some folder, not data, right? This is some folder. So now so what next step, please tell me. So we are initialize the data value, we initialize the sample data, we initialize the M, and we initialize the C. So what next? We already discussed here, right? So what we are going to do here? First, upload your data into the Google Colab. So this is my data. Right? So what next? What next? I have to read the data from this Excel file. Then what do we do? Copy path here, copy path, and go here and paste. Okay, that's it. We can run the code. Now it will give the H means pH, X means pH value, Y means bicarbonates of the well water. Okay.
What
So what
is that data dot head?
madam?
Data dot head is for
Okay,
what?
data
The
dot,
last
okay,
line.
right. So first attach it to my variable called data. So now with the same object, data variable dot head means data dot head within the bracket. That means it will print the head. That means top 5 values in your data
heading,
set that will be printed.
Yeah.
So the top 5 values will be printed here. Just only to visualize the data only I am writing. Nothing will do with respect to your learning process.
Yeah.
That's it. So we got the data. Initialization is completed. What next? Initialization is completed. What we are going to do next? Initialization is completed.
Gradient, yeah.
So here, before going to split the data, we have to do one thing. Previously, when I am using the previous example, most of the values are very, very small values, almost near to 1. If you observe the previous data, almost very, very small values. All are the very, very small values. All are between the 0 to 1 only in the same range. I am using as it is. But, sir, hello. Is it okay? Or anyone have a doubt? Okay. Okay, so it's okay. So, but here what you can see, you have the different values in the real time. The different features have the different values. I'm trying to explain one thing. That's important. Okay. So let's assume I am working on a COVID disease prediction. I want to build an application to predict the COVID. So that my output variable is a COVID variable. So the output variable expecting either 0 or 1. That means yeah, the COVID or not. If it is 0 means no negative. Okay, and it is a 1 means COVID positive. Let us assume. So based on which features we are going to predict generally, what are the features which can be used, what are the symptoms which we can use to predict the COVID? Maybe let us assume cold, okay, fever, maybe cough, and maybe O2 level, right? So let us assume the person has the no COVID, but is the temperature is 90 degrees Fahrenheit and no cough and oxygen level 100. So definitely is no COVID person. And take another example, maybe some person has a COVID, he has a cold and his fever is around something like 99.9, something like that. He has a cough and his O2 levels are very less, 90, then there's the possibility of the COVID. Some other case we can consider, again, is a 0 and the temperature is around 98.6 and no cough and the O2 level is 99. So it is so like that we are collecting the various samples from the hospital. Previous data from the diagnostic reports, I'm collecting the data. Now, these are the 4 features which I want to use to predict the person has a COVID or not. So these all are called as the input feature. This is called as the output variable. But see, if you observe here, so your cold and cough values are between the 0 and 1 only. And where the fever is high value, 98, 99, 98.6, sometimes more than 100 also. Whereas O2 is 100 and below 100. So these 2 values are the very large and these 2 values are the very small. So this is the uneven distribution. And there's a possibility that the prediction of a model is highly biased or highly affected by these larger values. There's a possibility the prediction of a model, the prediction, code prediction by a machine learning model may be highly biased, highly influenced by these larger values. Then what we will do is we are trying to normalize this data. We are trying to normalize this data. So normalizing the data means we are trying to scale down the data between the 0 to 1. We are trying to scale down the data. We are trying to keep all the data in the uniform range. I want to scale down the data. That is called the normalization. How we will do the normalization? So normalization, that if you have X value, its normalized value equal to actual X value minus what is the minimum value divided by what is the maximum value and what is the minimum value. So based on that, we can normalize the data, right? So for example, if you want to normalize the fever column, let's assume, then what happened? The actual value is 98. And what is the minimum value in this column? Again 98. What is the maximum value here? 99.9. What is the minimum value? 98. So what is the value here? 0. That means this 98 is replaced with a value called 0. Now go to the second one, 99.9. If you feed the 9.9 here, 99.9, 99.9 minus 98 divided by 99.9 minus 98, that is equal to 1. So this value is mentioned as a 1. And what about 98.6? Now what happened? 98.6 minus 98 by 99.9 minus 98. You got some value between the 0 to 1, let's assume some 0.2. So now replace this one with the 0.2. Like that, all the columns are normalized or scaled down between the 0 to 1. That is required in actual implementation of any machine learning project. I am adding different features one by one. Okay. So how we will do the normalization? Actually, we are using this formula, but you don't need to write the code from the scratch. You have the libraries are available, so you can see. So please, I am requesting. So mute yourself. If you have any question, please unmute yourself and you can ask. Or you can use the chat box also. I will give a reply. Right. So what we are going to do next step, we are trying to normalize the data. Whatever the data is available here, we are trying to normalize the data. Now for easy of understanding, this data, what are the variable I am using here? Instead of data, I want to use data original data. This is not normalized data. This is the original data. Now I'm changing the variable. That's it. Okay. Now what we are going to do? Whatever the original data is available here, I want to normalize the whole data. So how we got? So normalized data is equal to the variable. You can use any name and pass X minus X minimum. X means your original data minus what you want? Minimum in this case. Okay, ne? X minus X minimum. How we got the minimum value? Same original data dot min. So it will give the minimum value divided by maximum value minus minimum value. That means your data original dot max value minus data dot original, data underscore original min value. So it will give your normalized data. It will give your normalized. If you want, you can print. You can print data. Data is nothing but your normalized data. Just here I am doing the normalization. You can see. So all the values are between 0 and 1. Initially, these are original values. These are normalized data. This is the normalized data. If you want to see only top portion, so data dot head. So it will give the only top values. So top 5 values. So it's the normal values. So rest of things are same. I don't change. But that's the reason I want to use the data variable here. Okay. So rest of things you can go with same thing. I think I gave this assignment in yesterday. I think so. Next thing is just print the data, Control A, Control C. Okay. So same thing we can use, split the data. Okay, splitting of the data is completed. Once the splitting is completed, what we are going to do? We are trying to training process, do the training process. So go for the training process. Go for the training process. Okay, what next? So if you want, you can print. If you want, you can print. So what are the M and C values? You can print. So the M value equal to minus 0.2426 and C value equal to 0.78. Okay, I already explained all these codes, right? That's why I'm skipping. So next thing is you can convert all that information into the array format from the data frame to array conversion. After that, so calculate the predictions on the training data. Calculate the predictions on the training data. And also calculate the predictions on the test data. Calculate the predictions on the test data. Okay, calculate the predictions on the test data. Please listen carefully. Okay. Now, once the calculate the predictions, what we are going to do? Trying to calculate the errors with the training data and also with the testing data. So errors from the training data. So these all the things I explained. That's why I'm copying again. Same step, same piece of code I'm using. Only data changes. That's only data changes. Okay. And similarly, you can pass the calculate the data for the testing error.
బుధవారం కాదు విషయం ఏంటంటే ఈరోజు ఎంబీబీ మొత్తం సంకష్ట.
So once again, I'm requesting. So please unmute yourself. If you have any questions, please ask me. So you can see the errors. These are the testing errors. So testing errors are almost near to 0 and training errors also almost close to 0. So let's assume I'm happy with these errors. What next? This is a complete pipeline. Already I explained. Only additional thing what I'm doing is normalization. That's it. Additional thing that I'm doing is normalization. Okay. Now tell me, what next step? Already completed. What next step?
Do we have to the reverse of normalization? Do we have
Yes,
to do
madam.
it?
Yes, madam. Yes, madam.
Yeah.
So now let's assume I am happy with the training process. I am happy with the testing errors. I'm happy with the training error. So I'm trying to deploy my model, right? So let's assume if we deploy our model, so what is showing m equal to how much we are getting? M value minus 0.24. M value that's equal to minus 0.24 and C value equal to 0.79. C value equal to 0.79. So as per our analysis, what we are going to do next step, we are asking, because we are developing an application to predict the number of bicarbonates based on the pH value. Okay. So let's assume pH equal to, so we have to ask the user to enter. Input enter. So enter pH value of water. Enter pH value of water. So once we got the pH value, what next? We got the input from the application. From the front end of the application, the user will enter the pH value. So what next we will do?
To normalize this.
We will discuss. So we have to normalize actually. So let's assume I
Yeah.
forgot to reverse denormalization. What it will happening? Then bicarbonates equal to, how we calculate the bicarbonates? M multiplied by pH
pH.
plus C. Is it okay for you need to do anything here? Forget about the denormalization. We will do that. So as of now, is it okay or we need to do anything? Because pH will read it as a string. We have to convert it to a floating point.
Float. Yeah.
Float point. So convert it as a float point. Now we want to print the number of bicarbonates. Print. So maybe you can take a number of bicarbonates in water is equal to percentage and 0.2F, comma, where it have bicarbonates. Okay. This is how we will build the application. If you run this one, you can enter the pH value something like 7.4. Then what happened? Showing it bicarbonate is minus 0.96. Bicarbonate is 0.96. So number of bicarbonate, some value we have to tell, but it's showing the minus 0.986. Why? Because the model was trained based on the normalized data. The outputs what were compared here also based on the normalized data. So output, it is coming also a normalized output. But actually we want the actual output. So we are going to reverse back. We are going to reverse back. And one more time, when we enter the pH value like a 7.4, but your model expecting the normalized pH value, not actual pH value. I think it's clear, right? So user as an operator, I will enter the pH value of water. I measure the pH value in the water, I will enter that one. That no need to be between the 0 to 1, normalized one. So what we have to do inside, we are going to normalize the pH value separately, and normalized pH value we have to give, and it will give the output. But you have to understand here, the output value will be given with a normalized value because it's trained in that manner. So you have to reverse normalize this one. That process we have to incorporate here. That process we have to incorporate here. You can see all are same. For to do that thing. So to do that thing, first of all, we need to find what is the value of the pH, what is the maximum value of the pH, what is the minimum value of the all the things we need to calculate. So let's assume before here, I want to do one thing. Before going to the application development, I want to do one thing. I'm trying to calculate the minimum value, pH minimum value. Anyone tell me, I want to calculate the minimum value in the pH and minimum value of the, I want to calculate the minimum value of the pH and I want to calculate the maximum value of the pH in my data. Then my original data is data underscore OR, data underscore OR, dot min. Why I'm keeping the 0 here? Why I'm keeping the 0 here? And why I'm keeping the 0 here?
Because it's the first column.
Yes. Because my pH value in the first column, I have to keep the 0. Then it will give the pH minimum value. It will give the pH maximum value. And whereas in case if I keep 1, that is the second column. That is the bicarbonate minimum value, bicarbonate maximum value. So those values we have to print. So we have a question. Why we need to calculate all things? So this is the pH minimum, pH maximum. Bicarbonate minimum value, bicarbonate maximum value. Why we need to calculate all the things? Because we need to reverse it. So how we calculate the normalized value equal to actual value minus minimum value, either pH bicarbonate, minus maximum value minus minimum value, right? So I want the actual value now. I have to normalize, do it like this. If I want the actual value, then x equal to our normalized value into maximum value minus minimum value plus minimum value. That is the reverse normalization. These two things we need to incorporate. Okay. So for that, so see, so in a deployment, in addition to the M and C values, you need to take all the pH minimum and pH maximum values also. We have to take the pH minimum value and the pH maximum value, all the things we have to incorporate. So pH minimum value, maximum values I am incorporating. So what next? Now user enter the pH value. Once the pH value is entered, it should be normalized. When the pH value is entered, it should be normalized. How we normalize the data? How we normalize the pH value? Actual value minus minimum value minus maximum value minus minimum value. Sorry, actual value minus minimum value divided by maximum value minus minimum value. X minus X minimum divided by X max minus X minimum. Okay. Now this normalized value we have to pass the model because we are trained in that fashion. Now we are getting the bicarbonate. So bicarbonate is the normalized value or what is actual value? It will give the normalized value. We have to reverse this one. How we reverse this one? We have the formula, right? We discussed already. Normalized value into maximum value minus minimum value plus minimum value. Then we will get the actual value. So how we will do that one? So you can, so I don't want to copy. So we have the code here. Yeah. So bico, I am using the variable bicarbonates. So bico normalized output I am getting from the model. And that normalized value I am passing here. how we get, see, you can see here, I can, actual value equal to normalized value into maximum value minus minimum value of the bicarbonates plus minimum value of the bicarbonate. That's it. So you can print the bicolumn. Like that, we can build an application. So maybe you can write something like a 7.4. So it will give the 196 bicarbonates are available in the water. You can give some other value, again run the application, and it will ask something. So you can give something 10 pH value. So that's the value 128. So like that, your application will predict. So based on the pH value. So is it clear? This complete code is clear. If you have any doubt, please ask. Otherwise, we will take a break for the 15 minutes and we will join back by 3:15. So any questions, please?
Sir, how do we apply optimization, sir? In this case?
Here, sir, we applied, sir, optimization we are applied here, you can see.
Sir.
This is the optimization we are applying. We are applying the gradient descent algorithm, this part. During the training process,
Please-
we applied the
Sir,
training.
please share your screen, sir.
So this one, sir. We are incorporated the gradient descent algorithm while training. This part is the optimization part. This is what we discussed yesterday, and today also we repeated same thing. So this is for the
Sir,
well water bypass.
So training in the sense in general, we use a technique like we create object for a linear regression model.
That is actually when we are in the library.
After creating a object, we use a method called fit method.
Right,
And
sir.
then we use X values
Right,
and Y
Right,
values.
sir. Right, sir. Right, sir.
Uh,
So that is the usage of the Python libraries
yes, sir.
to
Yes,
train
sir.
the model. But here I
Mm.
am trying to explain the optimization, how the backend works.
Mm.
Dot fit backend, it will be works like this.
Okay, fine, sir.
That is the
Listen,
what
dot,
we-
and when we use dot fit, automatically this code will be run in the
Yes,
background.
sir. So that's why we started this course as a basic course. We have to understand what happened behind the models training.
Okay.
When we are
Mhm.
using the libraries, just we are passing object dot fit, pass the train data and train input, test train output, then it will train. But how
Mhm.
it will train, how model parameters will update, and where the optimization come into picture. That's what we are
Mhm.
discussing about this.
Mhm.
And how we are getting this one, all the things we are discussing from the last 3 days. Initially, we took a very small object function f of x equal to x square plus 2, and we applied the gradient method and we write a code. Later, we are going for the multivariable and we write a code. Now we apply the same
Okay, sir. I got your points.
things we discussed that. So based on that one, it is.
And you're doing manual training using this mathematical notations.
Yeah, that means from the scratch, I'm trying to explain how it will be happening backside.
Yes, sir. Yes, sir.
Otherwise, it will be like a black box. Just we are feeding the
Yes, sir.
some
Yeah,
data.
mission,
it
it is
will
a
train,
black
it will-
box only. Yeah. Yes, sir.
So just only at the initially we had to, of course, we need to write this code when you go into the real-time application development.
Yes, yes, yes.
So
But
finally, they are
I
asking the
thought,
application.
yes, I initially when I have gone through your browser, I thought that you are using machine learning and optimization together. Like, see, there are so many optimization techniques are there in real
Right,
time.
sir. Right, sir.
So
Right.
maybe those are applied in line with the machine learning. The integration
sir.
of optimization with machine learning. I thought that is a hybridization of kind of models will be.
No, here we are actually maybe think you are aware of something libraries. Maybe if you are using the ANN or CNN anything, we are passing some methods like SGD,
Yes.
optimizer equal to SGD, like that we are passing. And
Yes,
how
sir.
it will works. That's how it work in the backside.
Yes, yes.
Okay.
Yes, sir, I got your points. But
Yes,
now
thank you.
we are moving towards using the machine learning models as objective functions in optimization
No,
techniques.
sir. Here it is a completely course is about next optimization we are moving. Next one is the batch gradient optimization. So how this batch
Mhm.
gradient optimization method will use to update the model parameters.
Yes, sir. Yes. Okay,
So
then you are
later-
only, you are speaking about the back-end procedure, which is
Back-end
applied in
procedure.
machine learning.
various optimization methods, how helps to train the machine learning models.
Hmm. Okay, fine, sir, fine, sir.
Next. So we will take a break for the 10 minutes and we will join back by 3:15. Right. So now we are going to discuss about all are the slight variants of the different optimization techniques. So another one is called batch. Another optimization, previously the stochastic gradient. Now we are in the batch gradient descent optimizer. Batch gradient descent optimizer or optimization algorithm. So we are going to discuss about the batch gradient descent optimizer or optimization algorithm. Okay. So anyone is available, please tell me what objective function or error function I used in case of the stochastic gradient descent algorithm. So please, anyone from the participants, so can you please tell me what error function or cost function or objective function that I was used to as a error function in case of the stochastic gradient descent algorithm to train the machine learning model? Anyone, please? My question is, what the error function or objective function or cost function I used while training the simple linear regression model using the stochastic gradient descent approach?
It was the predicted value minus actual value.
Yes, madam. That expression
Yeah.
we wrote
Yeah.
yesterday, that is, I think,
The square of the
yes,
difference.
1/2 times
Yeah.
of
1 by n. Yeah.
actual value minus predicted value. Predicted value means mx minus c. Why mx minus c? Because I am using simple linear regression model and square 10 I am using. Okay, madam. So
Yeah.
why I am using only 1/2? So actually our motto is of mean square error. Actual error function is of mean square error. That's equal to 1/2n sigma I equal to 1 to n ya minus mx minus c whole square. From then, whereas in case of the stochastic gradient descent approach, my error function is converted like this. Why it is converted like this? Why this error function is converted in this format when I am trying to use the stochastic gradient descent approach to train my simple linear regression model?
Well, when you have n number of samples, that is the.
But why here? In our data, we have the n number of samples only, let us do n equal to xtrain dot shape 0, the n number of samples only. But still I am using 1/2 only. Thank you, Madam Kalpana, Madam, for the active participation. It will create some interest for me
Yeah.
also. That's why I'm asking. And sometimes I'm searching for you whether you are there or not. So why?
No, I'm not able to get. Yeah.
So that is actually in the stochastic gradient descent approach. How many samples we are passing to update the model parameter at a time? In stochastic gradient descent approach, how many samples we are passing at a time to update the model parameter? In stochastic gradient, anyone please, in stochastic gradient descent approach, to update the model parameter one time, how many samples we are passing? If you can see here also, otherwise.
N
So-
samples, yeah.
No, actually we have the total n samples, but we are passing the one sample,
At a time,
And-
one, yeah.
one sample. That's it, right?
Yeah.
So in stochastic
Yeah.
gradient descent approach, we are passing only one sample at a time to update the model parameters. That's why we take the one here and one here, because to calculate the error, mean error, so we must have more samples, right? Then only sigma term will exist. Here n equal to 1, 1/2 into 1, 1/2. Sigma equal to 1 to 1. That's it. n equal to 1 because we are passing only one sample at a time. Then what is the error? Mean square error. N equal to 1 and here n equal to 1, though it is a 1 by 2, sigma 1 to 1. That means nothing, no need to require a sigma. Then ya minus mx minus c whole square. This may be a corresponding I sample actual value, a corresponding I sample x value. So anyone, I hope you understand. Actually, we discussed that class, maybe some miss. Is it okay, madam? You understood this one?
Yeah, so at a time, because we are giving only one,
One,
we have
so
removed
we are
that
taking
n.
the,
N is equal
because
to
here it is a
1.
mean square error. So mean
Yeah.
value means we have to take the average of all samples, but we are passing one sample only. So that's it, 1 by 2. But now in case of the batch gradient, we will pass all the samples at a time to update the model parameters. Not one sample at a time, but this time we are passing all the samples at a time to update the model parameter. Then tell me what will be the error function. Let's assume my training data, X train and Y train have, let's assume Y train and X train have total n number of samples, let's assume. If the X train and Y train has n number of samples, in case of the batch gradient descent optimization, as a batch, I am sending all the samples at a time to update the model parameters. Then tell me how we can represent this error function. In case of the batch gradient descent optimization method to update any machine learning model. Forget about the machine learning model. If it is a simple integration model, your architecture will be y equal to mx plus c. If it is a multiple integration model, your architecture will be y equal to m1 x1 plus m2 x2 plus so on plus c. If it is a neural network model, some other architecture. So that is the architecture will be, the mathematical background will be changes for the model to model. But I'm expecting error function. So what will be the error function if I'm using the batch gradient descent optimizer? Batch gradient means we are passing all the samples at a time to update the model parameter. In case of the stochastic gradient, we pass one sample and we'll update the model parameter and pass the second sample and update the model parameter. But whereas in case of the batch gradient, pass all the samples at a time and then update the model parameters. Now, if that is the case, what will be the error function? Let's assume my dataset contains the n number of samples. All training samples, all training data samples are passed at a time to update the model parameter. If that is the case, then what is my error function? Anyone from the participants? Why it is only like this one? Why it is only 1 by 2?
Because at a time only one sample is being
Yes, madam.
processed.
Now,
Yeah.
if that is the case, now tell me what will be the error function
For
in case of the batch gradient?
same thing, half y square, y actual.
Okay, it's okay. I'm okay. Y actual value minus my predicted value whole square. Now, I'm passing all the samples at a time, madam. So, my error will be mean square error of mean square error 1 by 2n sigma I equal to 1 to n. So, this is my error function because I'm passing all the samples at a time. Previously, I'm sending only one sample. So, n equal to 1, n equal to 1. 1 by 2 into 1, 1 by 2. And I equal to 1 to 1. That means no need of sigma. So simply this expression in case of the stochastic gradient. Whereas in case of the batch gradient, so this will be the expression. Now, is it clear? But once again, I will tell this thing otherwise. So how the learning process is happening here is, if you feed one sample to your model, one sample at a time, and it will give some prediction. You are passing one sample X and it will give the prediction. Now what it will do? It will calculate the mean square error. How we calculate the mean square error? Predicted actual value minus the predicted value whole square. Mean value. Mean value means total sum. What is the sample? Only one sample. I equal to 1 to 1 only. And 1 by 2 into 1 of mean square error. Actually, it is 1 by 2 into 1. That's why I'm using sigma equal to E error equal to 1 by 2 into Ya minus mx minus c whole square in case of the stochastic gradient. But now I am passing the all n number of samples, x1, x2, x3, x4. I'm passing all the samples at a time. Now, how we calculate the error? Error equal to my my actual value for the first sample minus my predicted value for that first sample. My predicted value for that first sample whole square, because it's the mean value. So plus my actual value for the second sample, my predicted value for the second sample whole square, plus and so on. My actual value for the nth sample, my predicted value for the nth sample whole square. So how we can write this error function? So E equal to sigma YIA minus YIP whole square, where I is varying from 1 to n. And I'm expecting the mean value. Mean value means 1 by n. And half mean, that is the 1 by 2. So this is the error function we are using in case of the batch gradient descent optimization method, because we are passing all the n samples of the training data at a time. Whereas in case of the stochastic, we are passing only one sample at a time. So it is 1 by 2 into YA minus YP whole square. Is it clear? Because that's only the change. We need to understand that's only from the simple integration model to the our batch gradient method. Is it clear, please?
Clear, sir.
Yeah, thank you. So now coming to the algorithm. So now coming to the algorithm. So our error function equal to, in case of the batch gradient, our error function equal to 1 by 2 into n. All samples are passed. Sigma I equal to 1 to n, and my actual value YA minus my predicted value mx minus c whole square. So this is my error function that I am trying to minimize. For a batch gradient descent optimization method, my error function is this one, and I am trying to minimize that error. So what is my ultimate goal of any learning algorithm? Any learning process, what is the ultimate algorithm? Our ultimate goal or ultimate desire of any learning algorithm, any optimizer is it try to update the model parameters of your machine learning model in such a way that your error or the difference between the actual value and the predicted value will be minimum. That means you are trying to minimize the error. You are trying to minimize the error. Now, comes to the optimization problem. Even though it is a machine learning model training process, but we are coming to we are seeing it one as a optimization problem. Because here we are trying to minimize the error. We are trying to minimize the half mean square error. We are trying to minimize the difference between the actual value and predicted value by updating the model parameters M and C. That means by updating the decision variables M and C. All right. So now it is our method. It is our objective function in case of the error function or a cost function in case of the batch gradient descent optimization algorithm. Batch gradient descent optimization algorithm. Okay. Now I want to apply this batch gradient descent optimization algorithm for the same simple linear regression model only. For the same simple integration model only. Okay. So otherwise, for slightly, I want to change. Otherwise, I want to change slightly, but it may increase the complexity of the problem. Okay, I will keep it as a simple linear regression model only. For a simple linear regression model, I want to train the simple linear regression model with this batch gradient descent optimizer. With the batch gradient descent optimizer. Okay. Now tell me what is the first step. Almost all steps are same with very, very slight change from optimizer to optimizer. So what is the first step? What will be the first step in this case? Same simple integration model. Okay. Only thing is I am changing the not stochastic gradient. Now I am changing it to the batch gradient descent optimization algorithm. So anyone, please? What is the first step?
Initialize the parameters.
Right. Initialize the parameter. So again, because it is a simple integration model, we have the same M and C model parameters. So you can initialize as M equal to 1 and C equal to -1. And next?
Eta value.
Eta value.
Box values.
Eta value, you can consider something like a 0.9 and also initialize number of epochs, let's assume initialize as 1,000 like this. So next, so M value, C value, eta value, epochs value. So what else we need to initialize?
We need the data.
Right, madam. So good. So again, we need to initialize the data also. We need to read the data also, X and Y values. And we need to read the number of samples required. So what will be the step 2? What will be the step 2?
Iteration, sir.
We can initialize our iteration. We are going for the iteration. Iter equal to 1. Next, what is the step 3? What is the step 3? If you are able to identify this step, then I understood that you understand the BGD, what I am saying. What the step 3?
Sample one, sir.
No, sir. No, it is not sample one. Because in case of the batch gradient, we are not passing the sample by sample. No need to take the sample by sample in this case. You no need to take the sample 1 and update sample 2 and update sample 3, update, not like that. For one iteration, one update, that's it. In the first iteration, pass all the samples to your model and update the model parameter and go to the second iteration. That the process will be happening. So if you have some confusion, I will explain one thing. So in this case, iteration, pass the sample, and for each sample you have to update the model parameter and going back to the next sample, and this will be repeated until all the iterations are completed. But whereas in case of the batch gradient, it is the iter and pass all the samples, update the model parameter and go to the next iteration. This will be repeated. So you no need to take from the sample 1 and feed the sample 1 data, update the model parameters. No need to do like that. You no need to do like that. So what you are going to do, you are trying directly go to your step 4 in the stochastic gradient will become the step 3 in the batch gradient. Your step 4 in the stochastic gradient will be treated as a step 3 in the batch gradient algorithm. So what is the step 4 in the stochastic gradient? What is the step 4 in the stochastic gradient?
GM.
So step 4 is equal to
GM and GC.
GM. So GM is equal to, how we calculate the GM value? That is nothing but the derivative of the error function with respect to the model parameter. So what is the error function now? This is my error function, right? This is my error function. You can see this is my error function in case of the what's called batch gradient descent optimization method. Now what the dou E by dou M? This 2 comes forward, then it will be 1 by 2. We have the sigma I equal to 1 to n YA minus MX minus C So small request, actually I want to share this recording to other participants also. If you want to some other work, please mute yourself, please. Okay, so YA minus MX minus C, these 2 come forward, right? So these 2 come forward. So this 2 will be cancelled actually. Hope, right? This square term is there, right? What is the derivative of this one? These 2 come forward, 2 will be cancelled. Actually here we have the 1 by n. Sigma equal to 1 to n, YA minus MX minus C. What next? M coefficient is minus X. So minus X. So this is my GM value. And what is the GC value? So GC equal to so dou E by dou C. So dou E by dou C, that's equal to, so what is the value, please? So derivative of E with
Except for
respect
X,
to C.
yeah.
Yes.
Only
1
X
by
will
n
not be there.
sigma I equal to 1 to n YA minus MX minus C. That's it. That's only the change. Not only for this one, from this case to next algorithm momentum, if you go for the Nastran accelerated, if you go for the ADA grade, if you go for the ADA delta, if you go for the RMS prop, if you go for the ADA delta, or if you go for the NADAM. Suppose we are not going to cover all the techniques for these 5 days, but whatever the optimization method you are moving, so mainly change is at the time of the gradient calculation. Gradient step 3 and step 4 only changes. In step 3, maybe step 4. That's it. Only these 2 steps are changes from the one algorithm to the another algorithm. Okay. So we're getting the GM and GC. So what will be the step number 4 now? Rest are same. Anyone? What next step? What's the next step?
Delta M.
That's it. So delta M equal to minus eta into GM and calculate the delta C equal to minus eta into GC. And step number 5. So M equal to M plus delta M and also calculate C equal to C plus delta C. So what the step 6? Anyone? What will the step 6?
Checking the iteration.
No, madam, because we are passing all the traces, all the samples here. That's why we are getting the sigma term here. We passed all the
Yeah, but
samples here.
the iterations. will have
Yes,
to be
we are
done.
going to check the iterations. So we are
Yeah.
going to update the iter equal to
Mm.
iter plus 1 and step number 7. So you have to check if the current iteration value is greater than number of epochs that we initialized earlier. If it is a
Yeah.
true, so where to go, and if it is a false, where to go. So if it is a true, if the number of current
Next.
iterations, next step.
Next
So we are
step,
going to the
yeah.
next step. If it is a false, where to go?
Back to step 2,
Step
3. Sorry.
3. Yeah, step 3, man. That's it. Step 3. That's it. So next step is step 8. What may be the step 8? Step 8 means it's true. Your iteration number is crosses your epochs. Then
We have got the final value of M.
right,
now.
man. That's it. So final update M and C values are whatever the model parameter. If it is a simple linear regression model, we have the M and C. If it is a multiple linear regression model, some other variable. If it is ANN, some other variable. If it is CNN, some other variable. So that will be changed. If it is a logistic regression model, some other variable. So model to model, the model parameters will be changes, but the process will be same. So once you got the MNC values, again feed your training data to these MNC values, calculate the predicted training and compare with the actual training, calculate the training error, and give the testing input data to this model MNC values and calculate the predicted output value and compare the predicted output value with the actual output value in the test data and calculate the error that is called the testing error. So if you are happy with the training error and testing error, then deploy this MNC, deploy this model into an application. The rest of things are same. Only changes in this case is the step 3. That is only the change from the stochastic gradient descent algorithm to the what's called batch gradient descent algorithm. I think it's clear. Now we
Where
will-
exactly, which algorithm will be used? Is there any norm like that?
No, actually, not only these two, stochastic gradient or batch gradient, this is called as one of the hyperparameter while tuning the machine learning process. It's called, there's a one parameter called batch size. Batch size. So batch size equal to 1 means it is like a stochastic gradient. That means one sample at a time. Your batch containing the one sample. Pass one sample and update the model parameter.
So special case of this actually.
And if it is suppose if you have the 100 samples in your data, if you set batch size equal to 100, then it is like a batch gradient descent algorithm. It works like a batch gradient descent algorithm. All pass all samples at a time and update the model parameter. But this is also not give much benefit. This is also much benefit. In between also we can change the batch size. We may call it as the batch size equal to 10. Let's assume you have the 100. I will explain. I think I will explain that part. So I think it's clear about this algorithm, right? So try to remember these equations because while coding we are using these steps. Rest of things are same. Only this part will be changes in the code. Okay. Now, madam asking what to do, where to go. So that I'm trying to explain. So there is a one more optimizer called mini batch. So I'm not going to, I'm likely give the some view about the mini batch, but I'm not going to implementing in the Python. So SGD means only one sample at a time. Let's assume my data containing the 100 samples. Now pass the first sample, update the model parameter. Pass the second sample, update the model parameter. Pass the third sample, update the model parameter. And pass the 100 sample, update the model parameter. It's all one iteration. Next, go to the second iteration and do it the same process. 2 passes, 3 update, and like 100
Are you
update.
showing some writing on the screen because we can't see?
Oh, thank you.
Yeah, okay, yeah.
No, not,
Now
you are
it's
not,
there.
madam? Now it is okay.
Yeah,
no?
now
Okay.
we can see, yeah.
Okay, okay. So previously, okay, madam, previous that gradient calculations, all the things previously what I'm writing.
Yeah, yeah, of course.
Okay. Fine. So this is how batch gradient is up process. And in case of the batch gradient, so stochastic gradient, in case of the batch gradient, how it will be happening is pass all the samples 1 to 100, all the samples at a time and update. Then one iteration is completed. Now move to the second iteration. Here also, again, pass 1 to 100 samples, 100 samples, and update your model. Then your second iteration is completed. That's how it's working for the batch gradient. Okay. So I will explain. Done. So I explained this SGD and also explained MBGD. Now, sorry, BGD. Now I'm going to the another one. MBGD. That means mini batch gradient descent optimizer. So mini batch gradient descent optimizer means it will pass a set of batches at a time to the model and to update. Set of batches at a time to the model and the update. So what it will be means, let us assume we have the sample, we have the sample 1, sample 2, sample 3, sample 4, sample 5, sample 6, let us zoom. And I am giving mini batch, right? This is a mini batch. Batch gradient descent method is all 6 samples will be passed at a time. SGD means sample by sample will be passed and updated. But in case of the mini batch, we have to mention batch size. What is the batch size? Let us assume I set the batch size equal to 2. Batch size equal to 2 means, so these all the samples will be divided into 3 batches. Why 3 batches? Every batch contains the 2 samples only. Total number of samples are 6. And every batch contains only 2 samples, then the total number of samples can be divided into 3 batches. So maybe S1, S3, 1 batch, and S2 and S5, 1 batch. Maybe S4 and S6 are in another batch. Like that, we are splitting into batch. Now, what we will do, we will pass this batch at a time and update the model parameter. And pass this batch at a time and update the model parameter. And pass this batch at a time and update the model parameter. Then one iteration is completed. Next step is again pass this batch, update the model parameter, and pass this batch and update the model parameter, and pass this batch and update the model parameter. Then the second iteration is completed. So like that will be happening in case of the mini batch gradient optimizer. So actually, while when we are using the libraries, sometimes you may ask one parameter called batch size. Suppose if you are giving the batch size equal to 1 means it's like a stochastic gradient because one sample, your batch contains only one sample. So give the one sample, update the model parameter. Give the second sample, update the model parameter. Give the third sample, update the model parameter. That's what is happening. In case of the batch size equal to 100 or 6, whatever it may be. So suppose batch size, let's take this one. The batch size equal to 6 means, so all the 6 samples we have to pass. And update the model parameter like a batch gradient descent optimizer. Okay. And in case of batch size equal to 2 means, so you have to split the whole data into 3 batches based on the your number of samples are available. Now pass the mini batch at a time. Pass this mini batch, update the model parameter. Pass this mini batch, update this model parameter, and pass this mini batch, update this model parameter. So this process will be repeated iteratively again. So I think you are able to discriminate what mean by the SGD, what mean by the BGD, what mean by the MBGD optimization algorithms in case of the machine learning. Is it okay?
Yeah, yeah.
Okay.
I understood that these are different gradient descent algorithms.
Only
But
few
are
minutes.
there
Few more
some-
are there.
for a
Few more are
particular-
there.
No, no. For a particular problem, is a particular algorithms more suitable than the others?
That we have to tune it. Maybe you can
Yeah.
choose the batch size equal to 1, apply SGD, and batch size equal to 6, apply BGD, or you can tune the batch sizes, then observe the errors. And
Yeah,
at which case, at which
All
batch
of them
size,
will give you the updated parameters. So they will give you one or the other model.
for the same model, one SGD may
Hmm.
give some M and C values, and BGD
Yeah.
will give some M and C values. MBGD may give
Yeah.
some M and C values. Finally, which M and C values will give the better result, we will deploy those M and C values
Mhm.
in application.
Okay. Okay.
So suppose if you understand this complete setup, so I have a small question. If anyone able to understand, let's assume I'm taking a very small example. Small example I want to give in terms of the MBGD mini batch, in terms of the batch gradient, and in terms of the stochastic gradient. Okay, so let's assume I want to use MBGD one term or BGD or SGD to update the simple linear regression model, to update the model parameters of the simple linear regression model. So during the training process, I consider iterations are 100. Let's assume my data set contains 10 samples, let's assume. Okay. Now my question is, in case of the stochastic gradient descent optimization algorithm, during the complete time, the complete process until it is coming out of the loop, until it completing the learning process, how many times M value, model parameter M value or model parameter C value simple linear regression model. And I want to train my machine learning model for the 100 epochs. And I have
Yeah.
a data with the 10 samples. Let's assume I am using the stochastic gradient descent optimization method. Then the question is, how many times the model parameter M or the model parameter C will be updated in this case?
1,000 times?
Yes, madam. 1,000 times. For one iteration, sample by sample update, right? For one iteration,
Yeah.
10 samples, 10 updates. Whereas 100 iterations into 100, that's equal to 1,000 updates will be happening for M. Same 1,000 updates will be happening for the C also. And what about the BGD?
BGD will be only 100, I think.
Right, madam. Only 100, because for all the samples, there is update only once. There is only 100 updates in case of the BGD. 100 times M will be updated and 100 times C will be updated. So number of updates in case of the M and C will be less in case of the BGD, and in case of the SGD, it will take more number of updates will be happening. What about the MBGD? Let's assume I'm applying the some mini batch means. So let's consider batch size equal to let's consider batch size equal to 2. Let's consider batch size equal to 2. Batch size equal to 0 means number of samples in that batch equal to 2. Batch size equal to 2 means number of samples in batch equal to 2. Let us assume. Now,
So there will be 5 such batches then.
right, madam, 5 such
Yeah.
batches. Then number of times M
So
updates and number of
500.
times C update. Exact, madam. It's the 500.
500, yeah.
500. Because for one batch it will be updated, later second mini batch will come, later third mini batch, like that it will be goes on. So this is how the number of updates happening in a model parameter can be calculated, can be analyzed. So if you observe this comparison, suppose I am giving the same 100 iterations, same 10 samples. Among this SGD, BGD, MBGD for the same simple linear regression model, which will take the more time?
Which will take more time.
More time, computation time.
I think SGD, sir.
SGD. It will take the more computation time because there is a more number of updates will be happening in case of the SGD. So 1,000 times M will be updated and 1,000 times C will be updated. That will take the more time. And what about the BGD?
That will be the least.
Least one, because only 100 updates here, BGD. So whereas the MBGD, that is based on your batch size, that will be between your SGD and BGD. Because if you take the batch size equal to 2, it is a 500 epochs. If you take the batch size equal to 5, then if you take the batch size equal to
200.
5, then it will be 200.
200.
200.
yeah.
So your number of model parameter updates will be between your SGD and BGD, and the time also in between the SGD and BGD. Right? So that's a comparison for these three algorithms. At the same time, one more thing, I am trying to give some analogy. So, for example, my professor gave one piece of paper which containing some 3 paragraphs of a information. Okay. So SGD is nothing but, now I don't know anything what is inside my document. My brain don't know what is inside my document. Now, when I saw the first word, if I'm trying to understand word by word, I'm trying to give conclusion from the word by word. If I'm trying to update my neurons word by word, that is called SGD. Let's assume something right. Rama is a boy, not like that. Let's assume some text is there. What happened here? So I'm updating word by word, like here. Sample by sample updation, like word by word updation. Let us assume Rama, Rama, updated in my as Rama, name is Rama, is a boy, is a boy. So my brain is updated boy. If I go for only if I hide these 4 and word by word you are updating, then up to this 4th word, I may conclude that it is a boy. But if I go to the 5th word, it is not. So no, it's not a boy, he's a girl. That means my neurons will be updated multiple times. I'm not getting the conclusion very fastly. Okay. That's like a SGD. So there's more number of updations. And BGD is nothing but, so you have to read the complete paragraph at a time and try to give your opinion. Complete all 3 paragraphs at a time and give that your opinion. That also may be somewhat difficult. Some models, some brains, maybe for me also it is difficult. Once it's completed the first paragraph and I go to 3rd paragraph, maybe I forget what is happening in the first paragraph. So that is like a BGD. So MBGD means, so try to read a small paragraph, some conclusion, and go to this 2nd paragraph. Try to link up something because I already remember this part. And go to 3rd paragraph and finally come to the conclusion. It's like a mini batch. So we can't say that this is the bad, that you have to tune how we are going to update, with how many number of samples we are going to update. In case of the SGD, 1, BGD, all, MBGD based on your batch size, that is mentioned. So is it clear the comparison between these?
Yeah,
Madam.
This example was good to understand.
Yeah. Thank you, madam.
Mhm.
So hope it's understand. Then I will move to the implementation of the batch gradient descent optimization in the both MATLAB and also in what's called Python. So for that we will stop for today, and tomorrow we will come up with some more new optimization algorithm that is called momentum. If you go for the SGD, if you go for the BGD, if you go for the MBGD, or if you go for the momentum, all are called the fixed learning rate optimization algorithms, because in all the cases we are set eta equal to some 0.9 or 0.1 fixed throughout the iterative process. So these are all called as the fixed learning rate based algorithms. And 5th day, if momentum completed early in the tomorrow, so then I will start the another part, later part of our class tomorrow. Otherwise, on the 5th day, I will explain the adaptive learning rate optimization algorithm. Adaptive learning rate optimization algorithm that we will discuss. No, but here we have the multiple optimization algorithm again, learning. Like in case of the fixed learning rate optimization algorithm, we have multiple, right? SGD, BGD, MBGD, momentum, Nesterov accelerated. Similarly, for the adaptive learning rate also, we have the multiple optimization algorithm, like ADA grade, RMS prop, ADA delta, ADAM, like that. So we'll discuss 1 or 2 in the adaptive learning rate, and we are seeing few in the fixed learning rate as. Now I will try to close this whiteboard for some time. For whiteboard I will require, because maybe if you are unable to remember that GM equation, then I will open this. Just give me time, please. So looks my mission was struck. Okay. Where is the gradient descent algorithm? MBGD expression? Yeah, here. So no. Oh. What happened? Okay. So I'm trying to explain the BGD using the sorry, looks my system. Why you have
MATLAB is, you have to install it separately or?
we have to install on our local machine, madam, MATLAB. And
Mhm.
actually MATLAB also cloud is available.
Mhm.
So, just give me some time.
Yeah.
Looks my system was hang. Okay. So I think you're able to see the screen, right? So can someone please respond? Are you able to see this MATLAB window?
Yes, sir.
Yeah. So now I want to open a new file to write the algorithm based on the batch gradient to train the simple linear regression model, SLR underscore BGD. To train the simple integration model. So SLR underscore BGD batch gradient I am trying to write. So what are the first two steps? CLC, in case of MATLAB, CLC, clear all. So what next step? Anyone please? We discussed already that flowchart, that process also we discussed right here. Yeah, this is the algorithm that we discussed. Now I want to write the code based on this algorithm. I want to write the code based on this algorithm. So please tell me what is the next step, first step. Anyone please? So that is the simple initialization.
Initialization.
So
yeah.
initialization, random initialization. So lower value I'm taking the -1 and upper value I'm taking the +1 and random initialization m equal to lower value plus rand multiplied by lower value minus upper value. So that is the m random initialization. Similarly, C random
And you
initialization.
will be getting minus numbers, right? Is that intentional? Low
In the
minus
set
up.
space,
Yeah.
there may be a negative value or positive value.
Yeah.
That's why I'm giving like this. You can give
Yeah, low
any
minus,
any
yeah.
range. we can give. So M and C values initialized. Later we have to initialize eta equal to something like a 0.9, and we have to initialize epochs equal to, let us as usual, I'm taking the 1000 epochs. So anyone tell me what's the next step? So I want to use the same data, read the data, right? So I want to use the same data what I'm using for the what's called for a previous stochastic gradient. So same data I want to use. 4.2, 3.4 for input X, this is the output. So data is data, this is the 0.2, 3.4 and 0.4 and 3.8. Right? So data also read. Next, what's the next step? So we have to see our algorithm. M initialize, C initialize, eta okay, epochs okay, X Y read, that means data, and N means
Sample size.
number of sample size. So N equal to how we get the sample information based on the size of data. How many number of
Yeah.
rows are there? Those number of samples. So size of data,
Data
comma 1.
Zero. Okay.
0 in case of our Python. Actually, Python indexing
Python,
starting
yeah.
from 0. In MATLAB
Yeah.
indexing starting from 1.
Mm.
So data comma 1, that's the first row. Sorry, first element is the row value. That's over. So what next? So all initialization is completed. Now,
First iteration.
yeah. So this
Mm.
process, step 3, step 4, step 5 should be repeated for all the iterations. So for iter equal to 1 to epochs and close this loop. Right? So within the iteration, what we have to do, what we are doing here, we are taking all the samples at a time and we have to calculate the gradient. This is the formula. So that means what we do, we have to pass the sample by sample, but don't update. Don't update here. Here we're passing the sample by sample to calculate the error and to calculate the GM. After that, we are updating. Clearly observe here. So maybe you I hope you understand what I'm saying here. To calculate the gradient, we are taking all the samples and calculate the gradient. After calculating the gradient based on all the samples, then use that gradient.
So another loop there.
Right.
Up to N. Yeah.
Right. So but here small logic I'm writing. So why I'm writing, you're able to understand. So just I'm taking the count equal to 0. So because why I am taking this one is because I have to take this summation. I needed this summation. So to do that summation, I'm using this count variable as 0. You are going to let you know why I'm taking. So now for sample equal to 1 to N, close this for loop. So what we have to do within the sample, we have to calculate, we have to pass the first sample actual value, multiply with M and input value, C this one for the first sample, and take the second sample and calculate this one and add it to the first sample. So like that we have to repeat. So what I'm doing here is, now I am adding count equal to count plus 1. Now what I have to take? Y, actual value. Actual value coming from data of sample, comma, actual output value. Output is available in the second column. For that sample, output is available in the second column. So 2. This is the Y, right? This is the Y. For that sample, whatever the second column value, that is the Y minus M already initialized multiplied by how we got the X value? M into X, right? For that sample,
Yeah,
X means
data
input. So
Data
data,
Yeah.
data of sample,
First row.
comma,
First
1,
column.
first
First
column,
column.
and minus C and multiplied by data of, that means X again. For M actually, for GM calculation. So data of sample, comma, 1. So hope you understand. Instead of this one count, because I want to use the 2 variables, right? For GC and GM, so I want to use some variables like G underscore M, one variable with 0 initialization. Another is a GC with 0 initialization. because for both I have to do. So I can't use the same variable and add like this. Now it will give the summation for all the samples. The summation for all the samples we will get. And there is a small, I hope you understand. Now coming to the GC, coming to the G underscore C, G underscore C and G underscore C. Any modification required here?
Last one is not there. Data as a
Last
sample
one we have to remove. That's it.
multipliers here.
So next thing is we are getting the G underscore M. So what happened? We are getting the whole summation. We are getting the whole summation. But if you want the GM and GC, what we have to do?
Final GMGC only we have to take.
How we will get? No, not final. Final
That
GM.
will
Final.
get it anyway here.
You have to incorporate this also. 1 minus 1
Oh,
by
yeah.
multiplication. So finally, after getting all the summation, GM equal to minus G underscore M. That is the summation divided by
N.
and GC equal to minus G underscore M divided by N. No, wrong,
Divide
right?
GMC, GC.
GC. That's it. That's it. So that's how we are updating. We are updating only once in iteration. You can observe see here. We're not updating, not completed. Okay. GM, GC, come next thing. As usual, remaining steps are same.
Yeah.
So del M equal to minus eta multiplied by GM. Del C equal to minus eta multiplied by GC. And next step, GM calculation, GC calculation, del M calculation, del C calculation.
Equal to
Updation.
M
M equal to
yeah.
M plus del M and C equal to C plus del C. That's it. You can close this for loop. I think
iteration, yeah, and
end here. That's it, end. So if you observe here, for iteration, we are updating only once. This is inside only calculate that summation, sum gradient for all the samples, but we are not updating the model parameters. We are updating the model parameters only once for one iteration. Whereas in case of FGD, this whole part inside the sample for loop, but now it is coming out of the for loop. That's it. That's the what's called complete code for this case.
Yeah.
Now print your M and C values. Print
no,
M.
to complete the iterations, right?
Madam?
For iteration, okay, it's a
Yeah,
for
it's
loop.
closed,
So,
madam.
yeah.
This for loop closed here, for loop also closed here. And C equal to, so percentage 0.2 F and comma M comma C. That's it. So if you run this
Compact.
code, just run this one, run, and it will print error. It's coming error.
Print.
Somewhere mistake. Yeah, I forget to F. Still. Okay. So when we are using the multiple languages, we have that confusion. So print can be used in the
Yes, huh?
Python. Print command can be used to print the variables in the Python, but in case of the MATLAB, F printf.
F print.
That's it. So we are getting the M and C values are 2 and 3.
Syntax is
Right. So our that's it. So once it is completed, as usual, our application. We are getting the updated M and C values. Just we are deploy the model.
Deploy.
Let's assume save this one as SLR BGD based algorithm and building some small application. Let's assume. Now applications we have to deploy the deploying a model in the application is nothing but the deploying the model parameters. So M equal to 2 and C equal to 3. And we need to ask the user enter the X value, input value,
Yeah.
input. So input enter X value, enter X value, And now we have to get the y value, y equal to m multiplied by x plus c, and we can print, sorry, fprintf. So this is the application actually. So fprintf output is equal to percentage and point to f comma where we have y. So here we have the, so that's it. Simply you can run this application. It asks the x value. You can give something like 0.2, then it will give the 3.4 like this. If you see the data for a 0.2, your output is a 3.4. So if I'm giving the 0.2, it is getting the 3.4 only. Suppose if I'm giving the 0.4, we are expecting 3.8. So is the 3.8. That's how your application will be predict something. Rest of parts are same. Only thing is how optimization algorithm will have to update the model parameter. This part. This is important. So is it clear?
Yeah.
Any questions here? Okay. Now we are trying to implement the same thing in the Python as well. We are trying to implement the same thing in the Python as well. Again, I will take the correct. So tomorrow we will work on another fixed learning rate, because why I am saying that fixed learning rate, in case of the SGD, you can see in case of the SGD, we are taking the fixed learning rate eta 0.9. In case of the BGD also, I am taking the fixed learning rate, that is the 0.9. It is a fixed learning rate. I am not, during the iterative process, I am not adjusting the learning rate. That's the fixed complete training process, complete algorithm. Whether the 100 epochs or 1000 epochs or 10,000 epochs, your learning rate is fixed. So tomorrow we are working on the one more fixed learning rate algorithm that is called a momentum. So after that, we will discuss about the need of the adaptive learning rate. And later, we will discuss about the adaptive learning rate based optimization algorithm. If time permits, we will start that one tomorrow only. Otherwise, it will move to the 5th day. All right. So now I want to open the a new Google Colab notebook. So I will share all the things in the WhatsApp group. So maybe in future it may be helpful for you also, and also to do the assignments if you want. So I will give the name as SLR, Simple Integration Model with BGD. So as usual, almost all are same. Maybe I'm doing the copy paste things only. So what the first step? So if someone tell me I'm doing the same thing, I will not write the code again. Most of the steps are same, right? So again, I want to work with the same application. That means what is called bicarbonates. Okay, we will work on the bicarbonates. Estimation of the bicarbonates based on the pH value. Estimation of the bicarbonates based on the pH value. But I want to use the simple integration model only, but that model which was trained with the batch gradient descent optimization method. Okay. So tell me, so what is the first step ever? So we have to import the libraries. Okay. So after importing the libraries, what we have to do? Initialize the eta, initialize number of epochs, initialize the MNC values, and also read the data. But if I run this cell, it will throw an error because it don't know where is this file. So we need to upload this file here. So upload that SLR file, that means the data file of a pH value, you can upload here. Now run this one. So what will the next step, please? Anyone, please? So we are reading the data. So what next step? See, our pH values are 7.6, 7.1, 8.2, 8.5 like that. And Y values are 157, 188, 171 like this. So what will be the next step?
Normalization.
Yes, madam. So we are going for the normalization. We are going for the normalization. we are going for the normalization. I am using the same thing, same piece of code. Just actual value minus minimum value divided by maximum value minus minimum value. That will give the normalized data. So after that, so we are getting the normalized data between the 0 and 1. So what next? So after data normalization, what we are going to do? As part of the real-time project, like we have the around more than nearly around 100 samples, I think. I don't know exact number. So some more samples are there here. So what we are going to do next? We are going to split the data. We are going to split the data. So just use this one. We are going to split the data using the train split method, because I am using directly, because I already explained this one earlier. So train split method, what it will expect, what it will take, what parameter it will take, what is the impact of those parameters, and how it will split the data, all the things we discussed. What mean by the X train, what mean by the X test, what mean by the Y train, what mean by the Y test, that also we discussed earlier. Okay, so split the data. Split the data. So next is, so after splitting data, what next step? We are going to write the code, algorithm. We need to write the code to train the simple linear regression model, or to update the model parameter. Here we are going to change the code. Here we need to change the code. So anyone please, already we write the code in the MATLAB. So you can suggest me what I have to do, what changes I have to incorporate. We already discussed the code, right? Here in MATLAB code we discussed it. So same logic we can apply. So what are the things I have to incorporate in this code? Anyone please? Any idea? Okay, no problem. I will try to compare with this one. After iterations for loop, what I am doing?
Yeah,
Initializing
GM
GM
equal
and
to
GC.
0.
Right,
Yeah.
same thing I am doing. So
Yeah.
nothing I'm doing special. Just GM and GC initialization with 0. Next step, for this sample,
GM equal to
so
GM plus.
write G underscore M equal to G underscore M plus this expression. That's what we are
Yeah.
writing here also. GM equal to
Yeah.
GM. I think we did some mistake, no? No? Okay. We took minus sign here. Done. Okay. Fine. Right. So same thing I'm
Yeah.
reading.
Mm.
That's okay. So GM equal to, you can see here, GM equal to GM plus Y minus M into X minus C into X. So GM equal to G underscore M equal to J underscore M plus Y minus M into X minus C into X. Similarly, G underscore C, and here also. So have any doubt, please let me know. I will explain what I am doing here. Here I am incorporating this minus later.
Yeah.
Here we're adding, see, you can see, I am adding this part. Later I will add the minus sign. So don't think that I am not including this minus sign. I am including the minus sign later. You can see here. So coming to this code, so we are adding, right? Now close this for loop here. Done. Now del M calculator should be coming outside of the loop, right? You can see this is the for loop close here. So
Yeah.
there is no specific end. If it coming, this index means it is coming out of this for loop, but this is inside this for loop.
Yeah.
If it is index is like this, then this is in this for loop, but it is coming out of this index. So it is coming out of this for loop, but it is inside this iterative for loop. So iterative for loop should be there, but it's not inside the sample for loop. So del M calculation. So before going to the del M calculation, what we are going to do? GM equal to, I am including minus G underscore M divided by N. Similarly, GC equal to minus G underscore C divided by N. Same thing I'm using. GM minus G underscore M by N, GC minus underscore GC by N. So once you got the GM and GC, then we are going to del M and del C. Del M equal to minus 8 into dou A by dou M. Del C equal to minus 8 into dou E by dou C. Dou E by dou M, dou E by dou C. Next. And model parameter updation also within this for loop, not within the sample. So then what you have to do? Remove this M value and also remove this C value. That means move out of this sample for loop. Right? That's it. So I hope it's completed. Completed, right? It's completed. Now you can run this code. Now, if you want to print our M and C values, print M equal to percentage 0.2 F, comma, C equal to percentage 0.2 F, comma, M, comma, C. I think so. Okay. So you can print it. So it is not trained properly. Why? Okay, that's fine. That's fine. Okay, fine. So we are getting the updated M and C values. Update M and C values. So don't think that we are getting 2, 3 here, not here, because this is a different problem. I'm taking the only 2 samples that this is the estimation of the bicarbonate based on the pH values. That's it. So what next? So now only change is in this cell from the algorithm to algorithm. During the training process only the changes will be happening. The rest of part before this cell and after this cell are almost same. We can simply copy and paste. So if I'm giving some assignment, so only you have to more focus on this cell only. You have to do write the remaining all code as it is for this model, for the simple linear regression model. So what next? If the training was completed, what the next step?
Deployment.
No, before going to deployment, we have to calculate the errors. So calculate the errors. So first convert all this data frame into arrays format, and later now calculate the predicted output on the training data. Predicted output on the training data. Sorry. Okay. Predicted output on the training data. Okay. And similarly, calculate the predicted output on the testing data. So testing data.
What about the normalization? Normalization
that we can do at the time of deployment, madam. Here also we can do if you want. But here what I am doing is, even though I'm not reversing the normalization, but I'm comparing the normalized output with normalized predicted output also. So whatever I'm trying to compare, while calculating the errors, I am getting the normalized output, predicted output, and also I will compare with the normalized actual output. This is the normalized one.
So the error will be still
in the normalized range only, not a problem. If one is in the normalized, in another is the actual value, then we don't compare.
Yeah.
So this will be test, and you have to take the x underscore test, and x underscore test. What else? And we have to use something like a TS variable, change the variable name, and append that same variable into our text array, which is created null array initially, and that one converted as a numpy array. That's it. So you can run this prediction and the training data and also on the testing data. So once the predictions are completed, what next step? We are going to calculate the errors. So we calculate the errors. We can use test errors. If you want to calculate test error, so we can use like this. So, but it is throwing an error. Why it is throwing an error? Because we have to import those libraries. How we can import those libraries? From sklearn dot matrix import import. So mean underscore absolute error. Similarly, from sklearn dot metrics, import mean square error. Done. So then it will give our errors. This is the errors on the test data. And similarly, we can calculate the errors on the training data also. We can calculate the errors on the training data also. These are the errors. We no need to import these again because we already imported. So that's why I'm going for the next one. So these are the training errors. But it's showing an error because somewhere maybe y pred train. This one. And whatever the y train value, y underscore train. Yeah. So these are the root mean square errors for the training data. These are the, sorry, MSE, RMSE, MAE for the training data. These are all three error metrics for the testing data. So if we are assuming that, so if the errors are fine, then we are going to deploy the model. So deployment of the model we already discussed. So we can use the same piece of code for this one also, for the deployment of the model. So I think open something water, SLR SGD water. So you can use the so you can use the same deployment code. So this is the deployment code, right? So you can use the same deployment code here also. So deployment code, same, everything will be same. Only thing is that learning process will be changed. So whatever the M value I'm getting here, minus 0.4. I'm getting the M value as minus 0.4. And what the C value I'm getting 0.657. That means you can take it as a 0.66. So remaining parts are same. We need to identify the minimum pH value, maximum pH value, minimum bicarbonate value, maximum bicarbonate value. Now give the permission to the user to enter the pH value of the water and normalize that pH value and pass the normalized pH value to your model, and your model predict the normalized bicarbonate value, and normalized bicarbonate value should be converted into the actual bicarbonate value, and that bicarbonate value will be getting like this. So finally it will be printed. So maybe you can give something like a 7.4. So it will give the number of bicarbonates like a 154. That is your deploy. That's how the code behind the application will be works. So deployment of the machine learning model is nothing but the deployment of a machine learning model parameters and also its architecture. And we have to do some process back end of your application. And you then if the application, you throw the predicted output values like this on the front end. So this is all about the today's batch gradient descent optimization method and its use to update the model parameters of the simple linear regression model. So this is the things from my side for today. So if you have any questions, please ask. Otherwise, we can